Good afternoon, grade 8. Before I start the lesson, I'm going to make a revision for you to show you what is the atom, the parts of the atom, and the and the levels of the atom. Now, our lesson is mainly about organic chemistry, and the organic chemistry stands for the compounds that composed of mainly the carbon. Let's see the carbon here. The carbon here has this atomic number. Atomic number means the number of the protons. So the number of the protons in C, in the carbon, it is 6. Now we remember that the atom consists of 3 parts: protons, neutrons, and electrons. The protons is positively charged, the neutrons no charge, and the electrons is negatively charged. Now, the atomic number of the element is its proton number. The atomic number of carbon is 6. Now, let's draw this atom which represents the carbon. We have here 6 protons, so you have to separate them, okay, according to the levels. The first level can hold only 2 electrons. You know that the protons are 6, so the electrons should be 6 in the balanced atom, or خليني أحكي not charged atom. Okay, هلا هون we have 2 electrons in the first layer. Okay, the outer layer will hold only 4. As you can see, the green dots here represents the electrons in the outer layer. So 2 plus 4, we have 6 electrons. Now the second level and the third and the fourth, etc., it can hold 8. And to go stable, or to be stable, atoms always try to get 8 electrons in their outer layer. So the carbon here, it has 4. Okay, it has 4. So how many electrons it needs to go to the stability, or to have the stability? It needs 4 electrons. Okay, these outer electrons, we call them valence electrons. How many electrons it needs to go to 8? It needs 4, other 4. So I draw them here in the pencil. Okay, these 4 means that it would, or it should bond with other atoms in order to get these electrons. Now atoms might make many types of bonds. It might gain, or it might lose, or it might share. Okay, I think you have studied this before. Now gaining means it take all the electrons as gaining from other atoms, and losing, which means lose these 4. No, the carbon doesn't lose, doesn't gain. It shares 4 electrons with other atoms in order to complete the outer level into 8. Okay, so the outer layer, it can hold 8 electrons. Okay, now carbon has only 4, so it need other 4 to make the outer level complete. That's why let's go to the beginning of our lesson. This is the reason why does carbon make many different compounds. Because of 2 reasons, 1 and 2. Look here, a carbon atom has 4 valence electrons. Now the secret to carbon ability to form a wide variety of molecules lies in the arrangement of its electrons. A carbon atom has a total of 6 electrons arranged in 2 energy level. As I show you, these are the 2 energy level. Okay, around the nucleus, this is the nucleus. Okay, 2 of these electrons are the inner level. This is the inner level. Okay, 2 of the electrons are in the inner level, the 4 electrons in the outer level. This is the outer level. Okay, it will form bonds with other atoms and are called valence electrons. So this is the first reason, because it has 4 valence electrons. Look at this. Here, locate and circle the bonds in the molecule below. Here are the bonds. Locate and circle, which means you are going to see these. This is the carbon sharing with the hydrogen. Look at the hydrogen. The hydrogen has only 1 atomic number, which means it has only 1 proton and 1 electron. So in the first level, we say that it can hold two. The hydrogen has only one, so it needs another one. So it will share with the carbon, with another one, to complete its inner level, okay, to reach the stability and to be stable, okay. Now this is another hydrogen atom and another hydrogen atom. So 4 hydrogen atoms the carbon will need to get 8 electrons. And here each hydrogen will get 2 electrons. So the hydrogen will be stable and the carbon will be stable. Okay? Now, the second reason is the carbon atom can bond with multiple atoms. Bond between two atoms always form in pairs of electrons. Okay, pairs like this, pairs. Okay? Sometimes one atom supplies both electrons in the pairs. Supplies, which means give or lose. Sometimes each atom in the bond provides one electron to the pair, which means gaining. Carbon atom form bonds by sharing their valence electrons, as I mentioned in the beginning. The bonds might be by sharing or by losing or by gaining. In the carbon state, it is sharing with other atoms. Because carbon has 4 valence electrons, it can form bonds with up to 4 other atoms at the same time. So this is the second reason, is the carbon atom can bond with multiple atoms. Okay, now the second part of the lesson is how does the carbon form molecules. So we said that the carbon need to form or to share with other atoms. So the organic chemistry, it means the study of the organic compounds. And the organic compounds are the compounds that contain the carbon with other atoms. So the molecule, first, what is the molecule? A molecule is a group of atoms joined together by bonds. Okay? Carbon forms molecules by bonding with other carbon atoms and with atoms of the other elements. Most molecules that do not contain carbon have only a few atoms, because carbon has 4 valence electrons, so it can make many compounds, not like other molecules. Now, how they do the molecules? In different ways. Carbon can form single or double or triple bonds. Okay, a bond between two atoms that is made up of only 2 electrons is a single bond, which means this. 2 electrons, which means this. This is an electron. Here we have an electron of, here we have electron with carbon, shares with electron with hydrogen. So both of them will share in these 2. Okay, this is because it's one line, we call it single. Okay, here carbon can form up to 4 single bonds. Why? Because we have 4 valence electrons, so 4 single lines here, single bonds. Okay, carbon atom also form double and triple bonds. Let's see the double. Here the double means that the carbon share here 1 and here 1 and here 1 and 1. So look at this. We have here 2 and these are 2. So with the other 2, with the other 4 that it has, so it would reach the stability. Here the same thing. Okay, here are the same thing. So we have 2, 4, 6, 8. Okay, another time we have here like this. So the hydrogen will reach 2, this one 2, and this is, count them, 2, 4, 6, 8. This will has 8 and this will has 8 at the outer level, and here is the same thing. If you count these toots, you will have 2, and here also 2. So this compound is stable. Okay, this, because it is 2 bonded with the carbon, we call it double. Okay, double. This is a double bond. back. Okay. Double and triple bonds. A double bond is made up of two pairs of electrons, 4 electrons in totals. In total, I mean. Here, a carbon atom can form a maximum of 2 double bonds. Why? Why? Because if you get like this, these are 4. Put another one like here, you are going to get 4. So only 4 the carbon can share with, because it has only 4 valence electrons. So it can make only 2 double. Now, a triple bond is made up of 3 pairs of electrons, 6 electrons in total. Like this, 6 electrons in total. Let's count them here. 1, 2, 3, 4, 5, 6. So these are 6. Now, if I made another one like here, it's going to be 12, and this is impossible because the carbon can make only 8. So how many triple bonds can the carbon make? Only 1. Okay, here. So carbon atom cannot form more than 1 triple bond. A single bond is represented by 1 short line between 2 atoms. A double bond is represented by 2 lines, and a triple bond is represented by 3 lines. Now, here carbon molecules can form chains. Okay, so it can make single, triple, or double bonds, or it can make chains. A carbon atom can form up to 4 bonds with other carbon atoms at the same time. This ability to form bonds with other carbon atoms makes it possible for long chains of carbon atoms to form. Okay, so we have here like this green ones. These are the carbon. Okay, here it can make 4. So 1, 2, 3. Okay, they can just keep bonding together, making this long chain. Okay, the green ones represented by, or the hydrogen represented by the blue balls, and the carbon represented by the green ball. So like here, it bonds with 2 hydrogens with other carbons, and the one carbon can make another one and another one, and etc., till you get a long chain. Okay, now these chains can spread in a straight line or can be branched. Okay, remember this, please. The branches may also contain chains which add the size of the molecule. So like this here can make a branch, and let's go other ways. Now all the questions I made the solution, or I put the solution in your presentation. Now let's see the third section. What information does a chemical formula contain? Now if you have a chemical formula like this, it contains the type of the element, carbon, hydrogen, oxygen, and the number, we call it subscript before, if you can remember, the number of the atoms inside this molecule. Let's read. The type of atoms in the molecule. The letters in the chemical formula identify the types of atoms in the molecule. Chemical formula use the same 1 and 2 letters combination that are used to identify elements in the periodic table, and etc. It's very easy. Here the number of each type of the atom, as we say, the subscript show you like this one, C4H10, if only one atom of an element is like here, this, if a molecule contains 4 carbon atoms and 10 hydrogens, we represent them like this in this chemical formula. Okay, now let's see what are the types of structural formula. This is a structural formula. So how do we draw or write the structural formula? First, we are going to say what is a structural formula. A chemical formula tells you the types and the numbers. This is a chemical formula. Okay, now the structural formula, here types and numbers of atoms and molecule, but not how they bond together. Not how they bond together. Structural formula shows how atoms are connected. Okay, then the structural formula show how the atoms connected to each other, but the chemical formula shows only the type and the number. Okay, we have two types to show how the structural formula been like this. Full structural formula, which comes like in this way by single or double or triple bonds like this. Okay, for example, here we have CH4O. Okay, CH4O, which is the methanol. Okay, this is the structural formula of it. It is carbon. Around it we have 3 hydrogen, O, and then another hydrogen. This is the way they bond to each other in the nature. Now, we can see that the carbon and oxygen atoms are connected by a single bond. We can also see how the hydrogen atom are arranged around the carbon and around the oxygen here. Okay? Now, this is CH4O. Now, the simplified structure, we don't write it CH4O. This is a chemical formula. This is a chemical formula. This is a full structural formula. And for the methanol, okay, this is the simplified structural formula. It's the same thing, but without what? Without the lines. Okay, the same thing without the lines. You write H3 and then immediately you write the C and O and H. So C3OH, like this. We call it simplified. Sometimes we need to see how atoms related one another with the molecules, but do not need to see every bond. We don't want to see these. Sometimes this is a simple way. That's why we call it simplified. Then we can use simplified structural formula. The atoms bonded to each central carbon atom are arranged together. The simplified structural formula for the methanol is shown by this. So another time. This is the chemical formula. This is the structural formula. And this is the simplified structural formula. Okay? We call this full structural formula, simplified structural formula. You just put it without lines. Okay? This is how or what types of structural formulas we have. Now, where are organic compounds found? Organic compounds, we can see them in living things or non-living things. Okay? We use many materials that are organic compounds, and we eat things that are organic compounds. So in non-living compounds, as in nylon, fuel, okay, organic compound in non-living things were originally in living things. So that its origin, okay, it was a living thing. For example, the nylon is from petroleum, and you know the petroleum, it's from old, before million of years, living things were there and buried and etc. Okay, fuel, it's the same thing. Paper, it comes from the trees, as you know. Paper also is an organic material. Living things, we have them in a human body, animals, trees, plants. Organic compounds provide energy and structure for living things to grow and to change. How can we find the organic? We are going to see them in details, but the page after this. Okay? What other elements make up organic compounds? Not only the carbon. It might be hydrogen. Okay? It might be fluorine, chlorine, oxygen, phosphorus, nitrogen, sulfur. Okay? Chlorine, as I said. Okay? To make non-stick surface here, each one here, it has, or it gives something different. For example, if the carbon bonded with the fluorine, it gives non-stick surface. We use them in non-stick surfaces, okay, on the cookware. Here, if the carbon connected to the chlorine, it forms something called plastic, the plastic pipes. And if it bonded with the nitrogen, it forms the DNA, okay, which is the nucleic acid. here, how are organic compounds classified? It can classify it into many ways. So according to the composition and the structure, they can classify it into many things: hydrocarbons, organic acids, or carbohydrates. Hydrocarbons, from the name hydrogen and carbon, only hydrogen and carbon, is an organic compound that contain only carbon and hydrogen atoms. Okay, you have to know this and only the examples: oils and wax. Examples of hydrocarbons: oils and wax. Here, the organic acid. Organic acid is organic compound that has acidic properties. Okay, only the definition. So you have to know the definition only. Okay, and you have to know an example of it. We have here citric acid. You know where to find the citric acid. We can find it in the oranges, lemon, and etc. And this is the formula of it. Okay, this is the formula of the candle, the wax. See, only carbon and hydrogen. Here, see, oxygen is entered. Oxygen. So here we can say that the organic acids, okay, we can write like this: carbon, hydrogen, and oxygen. How they bond together? How they bond together? Something called carboxyl. You have to understand this also. Organic acids are identified by a group of atoms called carboxyl. Okay, this we call it COOH, which means in carboxyl group, one oxygen atom is double bonded to a carbon atom. Okay, the other oxygen in the group is single bonded to the same carbon atom. Look at this. Look at this. Carbon is double bonded to one oxygen and single bonded to other oxygen, which bonds to other hydrogen. Consists of carbon, hydrogen, oxygen. Here, hydrocarbons, only hydrogen and carbon. Okay? Now let's see the carbohydrates.